as we get started. Okay, well, thank you today again for joining us for the Internet of Things for Business Professionals. The audience, the primary audience for this webinar is those that are business professionals that need to better understand what IoT is and how it can benefit your business. And that's exactly what we're going to do today. We're going to focus on where we're going. What IoT is that it's the fact that it's a system of systems. We're also going to explore why it's important for business professionals to better understand the technology, which is really helping to shape our business today and into the future. My name again is Jeff Felice. I serve as the president of CertNexus. Just a little bit about myself. I've been in the technology sphere, if you like, mostly focused on education and certification for over 25 years now. Like many of you, I'm a resident and live in Georgia. I live about 45 minutes south of Atlanta. The focus, my focus really at CertNexus is to help two things. One is companies to essentially bridge their skill gaps, to bring more people into emerging technology, and for individuals themselves to provide a path to gainful employment. Just a little bit about CertNexus. We're a vendor-neutral emerging technology certification and micro-credential body. So we provide certifications, and we also provide training materials and offerings that map to those certifications. I will let you know at the end of this webinar, we are providing a free offer for readiness assessment, and if you pass that readiness assessment, you will receive a free badge, IoT Biz badge, that you can promote to LinkedIn or your other social platforms of choice. Just some folks, some companies that we do business with across the world. We are a small but global company. And I share this just to really show how pervasive emerging technologies, inclusive of IoT, is today. It really goes across all sectors, whether it's telecom or healthcare or technology, public-private, defense, and obviously you can look at retailers, whether physical or online, along as with banking, finance, etc. And this is the roadmap of products that we offer. We always show this just to show you the context. This is in our Think layer, which is again really aimed at business professionals. So typically, what we're going to do today is a subset of our IoT Biz course. This course is would be taught over a half day, and again, we're working towards a micro-credential. We're going to provide a shortcut to you and try to do as much information as we can in an hour today. And again, you can see we have other certifications in our build and secure layers for technical professionals. So let's get right into it. So what are we going to learn today? We're going to just, really before you can successfully plan and implement an IoT solution, and unfortunately, many are not doing this today, we really need to understand what it is, right? So we need to define IoT. We're going to then identify the components of IoT. And then we're going to examine the range of possibilities that IoT offers. And again, as you'll see as we move forward through the presentation, many times what's happening today is that business professionals lack the full understanding of the technology. And again, you don't need to understand it from a technologist standpoint, from a programming or a network engineer, etc. But what you do need to understand is what makes up an IoT solution, and more importantly, what can it do for your business? And this is more important for business professionals than traditional technologies. I always use the analogy that if you were in marketing or sales or the C-suite or operations, manufacturing, you really don't care whether you're using Windows Server or Linux Server. What you care about is you have access to the network, to browse the web, to email, etc. And someone may care whether it comes in budget. But with emerging technologies like IoT, these are shaping our businesses. It's determining what products we create, how we create them, how we bring them to market, how we engage with our customers, and how we influence that entire customer journey. So really, again, the intent of this is really to focus on that as we move through. So most of you probably have heard of IoT, or the Internet of Things. There's a lot of hype about it in the news, and we want to see if we can demystify some of this so we can understand what the ecosystem is and what makes up IoT. So a scenario like this is potentially possible today, right? Maybe not the go to work part, which is typically the end of this because many of us are working virtually. But the fact is we've introduced IoT into not only our business lives, but our personal lives, and the confluence of the two, right? So I can have an alarm that wakes me up in the morning at my optimum time when I feel like I'm completely rested, right? Now you can even see devices that are on your whether your wrist or even rings that help you do that as well. Your refrigerator door, right, can actually show you what's in what the contents of the refrigerator are, and then how do you start to actually add orders to your shopping list that goes out to Amazon or whomever, where you can actually have deliveries. Your smart speaker may inform you what meetings and appointments you have today, whether traffic is congested, right? You get into your smart car, right? And again, maybe not an autonomous vehicle yet, but your car is already started, it's warmed up the interior, it's set the speaker volume to your morning volume, etc. You obviously will spend most of the day with your smart watch or other smart devices. And then as you, if we were going into a physical office, right, you can even enter your office and receive a package from a delivery drone, right? And this was, at one point, for those of us a certain age, the Jetsons, right? It was the future. It was what could be. But today, much of this is, it is what we experience today. And again, with the proliferation of IoT, it's only going to intensify. So what is IoT? One definition is it's hardware and software that measures or actuates, and we'll talk a little bit more about that, real world attributes. So it connects to the internet, and that's the important part, because as you'll see, we've had other technologies that have helped us manage and control machines, but they were not connected through the internet. So really, what is it? It's connecting everyday things, right? Every day, whether that's in consumer IoT, or some of you may have heard of IIoT, which is industrial IoT. So they're all connected to the network, and they're sending vast amounts of data, as we'll learn more about, to the cloud. The cloud, once in the cloud, we're collecting that data, we're sharing that data, we're interpreting it, and in some cases, we're using it to back and actuate or control remote devices. And what is it doing for us? It's really, IoT has results in great efficiencies and improvements, economic benefits, and and reduced human effort. So we're able to increase global food production. Think about it, we'll talk more about it, but think about devices that are planted in the soil that are not only measuring moisture, but also acidity in the minerals, et cetera, of the soil, so you can better attend to your crops. Promoting safety and security, right? It could be everything from cameras, that CCTV, or within a building. Now, for those who have, your electronic doorbell, et cetera. And it can improve the quality of the life in our cities. The fact is that, as we'll learn more about, more cities are moving to smart city technologies. And as many technologies do, it's creating new markets and opportunities. And it's also going to help us potentially conserve some of the natural resources we consume today. So what are the ingredients of IoT? We're going to start with the IoT devices. Devices typically do three things. They sense, so they'll measure the world around them, such as temperature, humidity, number of cars passing, heart rate, etc. They're active, so they're able to take local action, such as turning off a light, opening a valve, or sounding an alarm. And they're able to share data, they're connected. And many times, again, we're sharing data into the cloud. They're also smart. And they're becoming more increasingly smart. In fact, we're starting to see devices now that include artificial intelligence. But even without that layer of intelligence, they're still performing some initial processing, determining whether action should or could be taken, and sending, again, taking action from other technologies in the ecosystem, such as the cloud. The cloud is really what makes a lot of this happen. So your cloud technologies like Azure, AWS, Google Cloud, IBM, et cetera, because this is where the data is collected. And again, it's huge volumes of data. You think about if you have a device, a single device sending something through the cloud, it can be every, literally seconds, and maybe minutes and maybe hours. But then you multiply that by the number of devices, and really cloud, the scalability and flexibility, as well as the security of the cloud, has enabled this technology to a great extent. And in the cloud, you're going to do that. You're going to collect data. You're going to combine data from your IoT devices with other data sources. And this is where you start to perform data analytics to identify problems. And as you'll see, you start to predict future maintenance as well. Finally, our client applications. With client applications, we have view into the data. So this is really where we start to take the data down and start to analyze the data for use for business applications. But we also may issue commands from these end user applications to remote IT devices. So I think about it on the really simple consumer analogy to use is, think about those of you who have a thermostat at home on Nest or Ecobee, whatever it may be, and the fact that's the device, and the fact that you can moderate or actuate that device through your smartphone, right? So you have an app on your smartphone, and you can set, you're going home, so you can set the air from 74 to 72 and do that. And essentially that is what's happening, right? You have that app on your phone, which is this client application. It's going through the cloud infrastructure, and it's now actually actuating or changing the state of that device, being the thermostat. And we'll dive a little bit deeper into the technology, but these are really the primary ingredients of IoT. So we started to talk about some of these examples. Consumer products, again, are, it's pervasive globally. Wearables, monitoring devices, and the monitoring not only, something on your watch, but right now people have monitoring devices from a health perspective, right? Whether that's diabetes or people with heart conditions, et cetera. We also many times see, as I talked about, thermostats, lighting. And again, this isn't only at home, but also now more so in business environments as well. I did allude to smart cities. And this is really an example of, smart cities and integration of industrial and consumer devices that are merging to provide really wholesale solutions. So that, again, could be anything from traffic monitoring, street lighting, but then we start to think about smart garages and parking, smart waste management, and facilities management. So it starts to impact the consumers that live within those cities. We have industrial monitoring and control. So now we move into that industrial environment. So think about robotics, environmental monitoring within an industrial plant, and many more applications within whether an office or more often than not in a manufacturing environment as well. So we talk about IoT and as an emerging technology, a new technology, but the fact is it has a long history. Albeit it wasn't always Internet of Things, but there was the connectivity, the capabilities to connect. So starting really, and some would say, prior to the 1970s, but really what we saw is in the 1970s is that we saw the ability to start connecting devices to machine for basic maintenance. And that was through programmable logic controllers, or PLC. Then SCADA came onto the scene soon thereafter, with the which is supervisory control and data acquisition. And that really started with mainframes. And also what you saw sandwiched in between there was machine to machine, which was really based on telecommunication protocols. So that started in the 70s, and you can see from the 70s really up through until 2000s, those technologies evolved, but for the inclusive of PCs and client server networks, which we're all familiar with, started to leverage some of that technology. But really the advancement of IoT and the movement from what we'll call what is really called an operational technology, which is non-digital. Again, non-digital being kind of in our world of digital transformation, it's kind of pre-digital transformation, although obviously it was using digital technologies, really occurred in the 2000s and has continued since. In fact, I was, prior to our recent virtual work, I was traveling. I have the fortunate opportunity to travel across the world often, and I was in a country outside of the US, and someone said, well, IoT is it even a technology anymore? It's so pervasive and so integrated. And it really has become, we don't always even think of it as IoT anymore. We think about the advantages as it provides, but not the technology. But this really has been the progression of that, and it has become so mainstream because many of the technologies we use to operate it and engage with have become so as themselves. And to that extent, we've really seen this evolution, and some of you may have heard of the term of Industry 4.0, and IoT has been one of the key technologies to facilitate this, right? So we all will remember from our history lessons, which was Industry 1.0, which was really the steam-powered engine, which changed how we manufactured goods, how we transported ourselves. That moved to mass production, most famously in the early 1900s, the Ford assembly line. And then in the late 60s, early 70s, we started to move to automation of using computers and robotics. And then in the 2010s, really, we moved away from just this massive automation through manufacturing process, really to this massive automation that's really interconnecting us globally, but also connecting us more with machines. Think about it today. Think about your lives. If you're, I'm assuming we're all, past 21, but think about your life 10 years ago, right? We probably just started to hold a device in our hand more often than not. Think another 10 years back, really we went to our devices, right? They were destination and they weren't as integrated into our lives. And they didn't have the power that they do today, that with voice, with touch. And so it's this fusion of not only technology with other technologies, but with our biological selves. So again, holds great promise, and we'll talk about there's some societal things that we have to consider as we move forward as well. So what enabled for IoT to reach the scale it has? It really comes down to, we actually categorize it into these 6 categories or 6 items that help to be the catalyst. The first is miniaturization, right? So if you look at the upper part of the image here, you can see that it shows one of the original computers, right? And this computer required 1,800 square feet of warehouse space and weighed more than 25 tons. And for all that, supposed computing power, it could execute 5,000 instructions per second. The iPhone at the bottom weighs, a little over 4 ounces and can actually compute tens of billions of instructions per second. So obviously miniaturization assisted us greatly. The second was connectivity. So obviously the ability to connect wirelessly in remote locations. So this is a variety of technologies, Wi-Fi, Bluetooth, RFID, etc. Also the advancement in power sources. So the ability to operate on very, very small amounts of electrical energy, like a lot of low wattage sources, right? And this also includes rechargeable batteries and the ability to harvest energy from the surrounding environment as well. In excessive processors, sensors, and actuators. So these parts have become increasingly produced on mass scale and at lesser costs. And again, these devices now are able, to measure their local environment. They've even though as they get smaller, they're able to process more data and respond accordingly. And as I shared earlier, we're now even starting to get to the point where we can start to put more intelligence within the devices themselves through the use of artificial intelligence. We've talked, already about cloud-based computing and processing, and this really, again, the fact that now not that the restriction is limitless, but almost it's seemingly the amount of data that we can actually send to the cloud and process through the cloud seemingly is infinite. Obviously, it's not at this point, but it is, and with quantum computing and other future capabilities, it's only going to increase more so. And ubiquitous computing, right? Earlier I said, how many of us 15, 20 years ago would have been walking around with the technology in our hand all day, and it wasn't available, and today it is. So, and these devices have user interfaces that can receive and send notifications. They can run applications to control and pull information from remote devices, and so forth. So really the power of computing and the availability of it is, again, one of those enabling technologies. So what's the promise of Industry 4.0? It really goes from what we would call the just providing visibility, to the what happened, all the way to the point to where we can talk about autonomous response. So right now you can see we can measure not as only what's happening in real time, but even predict with a high degree of accuracy and respond or actuate in a prescriptive way. So this is really a powerful new capability that we did not have in the past. And we're going to look at that in a little greater depth with what we call the 4 Ps of planned maintenance, which is preventative, predictive, proactive, and prescriptive. And this really becomes the power of much of industrial IoT. So if early maintenance practices were reactive, right? So if you think about, and again, don't think about just industry from a perspective of manufacturing floor, but anywhere where there was a mechanical component to it, right? And this could be transportation, right? Whether it's the trucking industry, airline. It can also be think about large amusement parks, right? Think about you can think about hotels and other hospitality industry, right? Where they have heating, cooling, and a variety, lighting, etc. So really think about this in the scope of, hey, it's not just on the manufacturing floor. So again, early maintenance practices were reactive. The approach many times was called RTF, or run to failure, right? You ran a machine till it failed, and then you sent someone to fix it. So, so really what has been developed are really these 4 methods of planned maintenance to further enable IoT. So preventative maintenance is exactly that. So it's really based on the mean time between failure. So we can start to understand when, if something is going to be 1,000 cycles, we're going to fix it prior to those 1,000 cycles before it fails. So you replace components and you reduce, downtime on, again, whether it's the factory floor, heating, cooling, whatever it may be. Predictive relies on routine inspections, and you start to predict when components are nearing their end of life. So now you're starting to gain a little more intelligence, especially if you have multiple inputs across multiple environments or pieces of equipment. And proactive builds upon that predictive. So now you're starting to identify not only when a machine may require maintenance, but what's the root cause of that. And you may start to remediate in different ways, find better components, etc. And then there's prescriptive, which takes it one step further, which is really the automation and measurement of the digital footprint. We're not going to get into digital twin technology here, but this really is the future of, I would say, maintenance, which is that more prescriptive, where the system now can identify itself the need for maintenance and prescribe its own solutions. So instead of sending a mechanic to fix it, the system understands that, hey, there's some potential wear, or there's a point of failure, and they can potentially remediate it itself, or at least reduce the point of failure until a human can engage directly with a piece of equipment. So now we've talked a little bit about the IoT ecosystem. We're going to, at a broader level, we're going to dive in and look at what are the components of the infrastructure itself. So as you would imagine, the IoT infrastructure can be very complex. Not in all situations. We're going to try to break it down to a handful of primary components. But you can imagine, talk about in a healthcare environment, in transportation, in agriculture, in manufacturing, in many other industries, telecom, et cetera. You could be talking about, thousands, hundreds of thousands, millions of devices, and the many ways that they need to connect. So we're going to try to boil it down to these 5 major components. The first is the devices. We've discussed these earlier, but here's some examples. Where devices now can be wearable, they can be stationary, they can be wired, such as cameras, they can be mobile. Think about transportation again, trucking, airline, etc. Next is the IoT gateway, and is your network connection, which is inclusive of the IoT gateway. And the IoT gateway, really what this does, it starts to act as the intermediary between your local networks and the cloud environment. So that your gateway is going to be a hub, router, switch, etc., that is within that local environment to that device, and is again, as we'll see, provides more computing power locally, and then starts to be the exactly what it says, the gateway to your edge and cloud computing. The edge is, again, where it's defined by points where the traffic leaves or enters the local network. So there's a lot of talk about edge computing, but simply it's the edge between local and cloud or internet connectivity. You have your global network, and that's really where your cloud sits, right? So many times, again, you're transmitting data over through the internet into a cloud infrastructure. Again, we've talked about some, the larger players, but there's obviously a number of cloud solutions. The cloud's solution, again, is where you collect the data from the devices. You start to, again, combine it with data from other sources. And this is where you start to do some initial analysis with various data sets. And then we get to the user interface. And as we discussed before, those user interfaces, again, can be mobile apps, web apps, desktop apps. And this is where you have the ability to view and analyze data. So we're going to just dive a little bit deeper into each one of the devices and then the software. And again, this is not meant to be a technical course, but again, just so you have an understanding, and I'm going to move through these a little more quickly so we can get to the business components. But when you hear of IoT Gateway, it's really, again, these devices are what supports the communication between the device and typically your edge computing and cloud infrastructure. They do some things preparing data. Again, a lot of the devices until recently would have less built-in intelligence. So the gateway starts to provide some of that first line of intelligence of what actually gets communicated from the device out to the internet, as well as when you communicate back to the device itself. The cloud services we've discussed at length. Again, it's really the central point where we collect our data. We can integrate other systems. And again, I've talked a lot about public cloud solutions, and obviously those can be public, private, or hybrid cloud solutions as well. The important thing to note with IoT is that when you're considering cloud is you need a solution that's going to scale. The amount of data, again, that you will develop or generate is significant, and again, will probably outpace most internal infrastructure. So you'll see many times it is a hybrid or a public cloud solution, albeit, as I said, you can do it internally as well. And then the user interface, as we discussed, just to dig a little deeper into this, really what we're starting to see now is, with consumer IoT, we're probably all familiar, right? If you wear some type of wearable device, whether it's a Fitbit or it's an Apple Watch or Android Watch, whatever it may be, I like to bicycle a lot. I use a Garmin GPS device, and then that links up into the Garmin Connect, but also Strava. And I can do all of that through my smartphone or through a desktop computer. And so I think we're all familiar with those types of user interfaces. For businesses, they start to become much more complex. And it depends on what you're trying to do, whether you're trying to extract data so you can operate your business, or whether you're trying to actuate the device, or potentially both. And so now you start to get into much more complex dashboards, much greater use of data and intelligence around that. And again, you may use that also to help to install, configure, and administer the IoT environment itself. Briefly, we're going to go through the software, and again, this is more just is just so you understand. A lot of people, when they look at the technology, they think about all of the computing power that is at the device level, and there is a lot there. But what you have to remember is that these devices have less intelligence than typically than the supporting other hardware and software in the ecosystem. And probably the exceptions may be like an Apple Watch, where there's a certain amount of computing power. But you still know that many times you may want to not essentially get data that your Apple Watch is sending to a user interface, as opposed to using just what's available on there. So again, the IoT device, depending, the OSs could be optional or very lightweight. Again, more in industrial applications, you'll see a hardware abstraction layer where you can use a programming interface to perform operations that directly program the device. And again, it's communicating out to the gateway, and it may be a single or bi-directional communication based on, again, the power of the device. You would expect in a more contained environment, or where you require less devices, typically the devices are going to be have greater intelligence. And when you get out to a more distributed environment, let's just take agriculture, where you're putting something in the soil, at that point the device needs to be more hardy. It's typically, again, providing useful data, but you're not seeing all of that as you would on your wrist, right? That device is going to really be transmitting that data to a broader infrastructure where you're going to view and analyze that data. The gateway we talked about, this is really, again, it's the interpreter, right? It's what is pulling the data from the device. It's a lot of the intelligence programmed in here to determine which then information gets sent onto the cloud, and vice versa. It becomes the two-way communication from the cloud and the end user interface back into the device itself. So it's one of those hardy hardworking pieces of the ecosystem that doesn't get a lot of fanfare, but is instrumental to the success of an IoT environment. And the last piece of software we've talked about extensively is cloud software. And again, for those, this is not intended to be a cloud training offering or session, but really what we look at here is, these, cloud technologies typically have more complex technology integrated within it. So we're talking about virtual machines that you can scale up or down on demand. The ability to communicate, the ability to transact, and then the ability to access it, and whether going out then to manage your device or its primary use many times for data management itself. So we've talked a lot about the technology. Now we're going to talk about the benefits and the challenges associated with IT. One thing I do want to note is in the full offering that we typically do is we typically then take this information and apply it to various industry. We're not going to get the opportunity to do that during the allotted time today, but I think that's of interest because you start to see, as you start to walk through some scenarios, transportation, and again, we have some great transportation companies in the greater Atlanta and beyond region, and the way they use technology to ensure the safety of their drivers, those around them, the timeliness of their deliveries, right? We're all relying on that more than ever today. And then it goes into the whole supply chain, right? As we're highly dependent on that today, from the the source of goods, its raw materials, and into through its manufacturing process, distribution, retail, and into consumer hands. So and IoT is facilitating a lot of that today. We're more, as we become more virtual, become more dependent on that technology each day. So, but here are a few ways that IoT can help businesses. So we've talked about the performing of predictive maintenance, right? So that's ability to anticipate and avoid expensive and time-consuming and hazardous problems. We can reduce operational costs, reduce the harmful impact of operations on our environment, increase our safety, and also improve the customer experience. So this allows us to identify possibilities for new and enhanced revenue streams as well. We talked about reducing operational costs and resource usage. It can reduce transportation. Do you have, for example, using IoT devices, whether it's not taking left-handed turns or driving certain hours, lodging expenses, impact on the environment, and really just improving our overall product quality and agility. Before you dive into IoT solutions, as a business professional or even as a technical professional, it's really best to solve for the three focus areas in this order. The first is value. So it's really key to understand what incremental or new value are you trying to add to your product or service, or to manage your environment. Many times we default to the data because the data is the easiest to collect. But the fact is if we're not driving value for the business, and whatever that value may be, right? Increased productivity, increased or decreased quality issues, greater uptime, greater safety to our employees, whatever it may be, you need to define what it's going to do for your organization and or inclusive of your customers. The next is, what insights are you going to gain from the IoT? So, now that you've clearly identified the value, what are you trying to add to your product or service that can, work to understand what existing or new insights you need in order to support that value? So let's just use transportation, right? We've defined that we want to reduce our energy costs, So our fuel costs, we want to increase timeliness of delivery, and we want to improve driver safety, right? So what's the information that supports each one of those values or objectives, business objectives that we're trying to achieve, right? So for fuel, obviously there's the usage of fuel, right? Which is very clear. Did I use 1,000 or 10,000 gallons of fuel this month, right? But it can also be that it's how that fuel is used, right? Associated to what products we're delivering to what individuals, right? Because if we're driving greater revenue, we need to understand, well, hey, maybe it's more worthwhile to expend more fuel for when we drive greater revenues. Talking about the ability to the timeliness, right, for our customers, right? So now you're talking about that, again, that whole supply chain, which may originate prior to your business, but maybe start with your business when you start to product leaves your door, right? And it's the same thing with safety, right? Talking about the number of accidents, the severity of accidents, et cetera. What's the insight that we're trying to drive? And then we get to the data. So now we know what the value is, we know what the insights we need. Now we start to look at what IoT can do, what data it can produce to support these insights and gain the new value. And again, the data, one of, as we speak to many IoT consultants and organizations that have implemented, many of them that started with a data first approach actually just have droves of significant volumes of data, and now don't know how to parse that data or have collected the wrong data. And again, so if you start from this top-down approach, you will have, the data should support the insights, which should support the value. Should you go, one of the questions I often ask is, should you collect data beyond what your initial defined data set? The answer is probably yes, but it may be 20% more data, not 80%. Some say, hey, we have the infrastructure and we know how to parse out the data we need. We're going to collect all the data and deal with the data wrangling at a later date. And that's a fine approach if your business is able to support that as well. So, what are the business challenges? The first is disruption, right? Through any organization that's going through a digital transformation requires change management. Especially for those who've been in the mechanical world, those what we'll call operational technologists or technologies that really required, hands-on pieces of equipment. There may have been, a simple interface to where they would, a person, a maintenance worker or service personnel would manage, several or maybe dozens of machines. Now, now they may be responsible for hundreds or thousands of pieces of equipment and or devices. So, how do you bring them along as persons, but also as you evolve your business processes and the infrastructure to support that. Provisioning and tracking thousands of devices, right? If you think about it, and we'll just use the trucking example again, right? If right now, if you have 500 employees and, you probably have 1,000 devices, each person has a computer, each person has a phone, right? And there may be some additional equipment in your data center, et cetera, but you're talking, 1,500. Now, if you are now attached everything to a driver, to a truck, to the trailers, it may be multiple devices per truck, right? Because now you're doing something under the hood, you're doing devices that are connected to other components of the vehicle, et cetera. You may now start to get into tens of thousands or even more types of devices. So how do you provision and track those? What's the value and cost, right? Is this going to be of value to your business, and does it support the cost that you're going to incur? There's obviously, and we'll talk more about this, but a business risk around security and privacy. You're going to start generating large volumes of data. How do you manage that data? There's many regulations, both at the state, federal, and international level about how you can use data and how that's regulated. So how do you go about, especially think about now in the healthcare environment with HIPAA laws, et cetera. If I have a device connected to a person monitoring, diabetes, their sugar levels, etc. Does that data all come in? Is that personal identifiable information? Does that get obfuscated? Or otherwise it becomes encrypted, and how is that data used, shared with research scientists that are attached to the hospital, et cetera. And we'll talk a little bit more about that organizational change and skills, but again, how do you bring people forward, whether that's already someone that hasn't been accustomed to using technology, or someone that has used technology like a networking engineer, but someone who now is going beyond that edge computing all the way out to those devices. And as of course, with any technology, there's going to be some technology challenges as well, or technical challenges. There's some constraints around the devices, right? You may want a device to actuate in certain ways. It's just not possible at this point. Maybe based on the limitations of size or price. Data communication. How much data are you able to communicate and consume? What does that look like from an infrastructure standpoint? Interoperability, this is a huge issue. A lot of times you'll see IoT projects get green lighted to move forward, and no one's thought about, hey, how is this going to work within our existing environment? Does it leverage some of our existing infrastructure, network operating systems, cloud infrastructure, other edge computing devices, software, etc.? It's now we're working in real time. So how does that impact how we operate our business and from a technical perspective? Again, we'll talk more about security, privacy, the usability. Again, you can generate vast amounts of data, but is it going to be usable and for your business professionals to make decisions, or for maintenance personnel to actuate devices? And then finally, how do you maintain it? Right, with any solution, it's not about the launch of the solution, but how do you continue to maintain it so it's viable long term as well? So the security challenge. There's a Twitter joke. It's been attributed to a person named Tim Cadlick, and I may be not pronouncing the name correctly. But the S in IoT stands for security. And you think about it, there's no S in IoT. And that's exactly the point of Tim's statement. IoT manufacturers, for a number of reasons, were initially slow to build in security into IoT solutions. In fact, if you look at it today, there's roughly 20 billion devices in the world today in 2020, and Gartner predicts by 2025 that there'll be 75 billion, so almost a fourfold increase of the number of devices. Yet there's this report from the state of IoT security said that 9 out of 10 businesses really lack the full confidence that their IoT devices are secure. And rightly so. And it's not, and this isn't a dig at the manufacturers of IoT devices. It's really how they go about being implemented, right? You think about it, if you're implementing 1,000, 10,000 more devices, each one of those devices have to be secured themselves. Where those devices live, typically outside of your network, and access to them, even the gateways, et cetera, become more vulnerable. So the need to actually secure those. And the next slide shows a really good graphic all the potential threat vulnerabilities. And I won't say it's not intended to be comprehensive. There would be others, but you can see with this is that traditional machine-to-machine applications were very focused on a single task using edge devices, but really IoT cuts across all the different sectors, and really because it embraces a multitude of devices and networks and communication technologies, satellite, cellular, et cetera. And then we move into big data, and they all present a potential threat. And again, the idea here is not to scare anyone away from the use of IoT technologies, but really to better inform ourselves that when we do implement IoT projects, security has to be a primary consideration, along with all the thoughts about the data that we're going to generate that'll be helpful to our business. Again, I won't dive into this too deep, but why are we lacking fundamental security? It starts with the lack of industry knowledge. So products are being added that previously worked in a networkless world, right? We talked a little about PLCs and SCADA earlier, and those were potentially networked, but within an organization infrastructure, they might have used more some telecommunication protocols, but for the most part were siloed off. And now it's not. The rapid time to market, we're in this iterative world now, right? Which is time to market is typically the greatest focus of a business, and we'll iterate beyond that. Well, security is something that you can continue to iterate, but when you first go to market, or interoperability within the environment, ensuring that what you're bringing into your environment is secure as what you have already in it. And then there's the lack of developer knowledge. There's software developers. We have some other statistics, but there's roughly today about 25 million people, roughly half of IT professionals, 25 million, use code or scripting languages on a daily basis. And many of those individuals have not received any training or nor their expectations, internal policies, procedures around the security of the code they develop. A lot of it is around, again, those iterative agile methodologies, which is bringing new products or new services or interoperability to market or to the organization, with a lack of focus on how securely they're doing so. There's a societal impact. Again, the machines can be very effective at performing tasks that are dangerous or risky, right? So increasing potentially safety. At the same time, it can potentially eliminate someone's job. We've seen this with manufacturing. And hopefully I'm getting the numbers right, but in the early 1970s, there was over 40 million manufacturing jobs in the US, and now there's less than 14 million. Some of that is due to offshoring, but the majority of that has been due to automation. Think about, if you watch an old clip of a Henry Ford slide or Henry Ford assembly line, the number of people that had to perform a single task versus now a robotic arm doing the same. And again, it may reduce manufacturing waste and natural resources, right? We talked about that predictive maintenance, so not waiting for something to work to failure. So the ability to do that, or to reduce pollution or the use of raw materials. But again, with a lot of technology uses requires it to be manufactured, and at some point is waste itself. And it's the difficulty of disposing or recycling IoT hardware once it becomes damaged, obsolete, or worn out. We've started to talk a little bit about the organizational impact. This is, and again, we have other statistics supporting this, but what we're doing today is the first step, right? You think about it, you have to educate business professionals, right? So whether it's the C-suite, VP, director level, first line managers, people that are in the various lines of business, project managers, they all need to have a better understanding of what this technology can do for them and what are some of the potential constraints. But then you also have to take your networking professionals who maybe are administering a Windows server or a Cisco router. How do they extend their skill set to be able to support this now extended infrastructure? And your security personnel, right? So how do they go beyond? Now you're taking them beyond the edge. So now they have to think about past their edge computing, and which most of security has been focused on, as well as your developers, right? Developers, threat vulnerabilities, the risk increases greatly if a threat is introduced at the code via a vulnerability in code versus malware or phishing. Malware and phishing are vastly more happening much greater volumes. But the likelihood of access to greater amounts of data or other damage to a company can more often than not happens with some type of coding vulnerability. So our key takeaways are really that IoT really has the ability to transform both old and new businesses, right? I look at the energy or transportation, which are now decades old, if not century old industries. Same with manufacturing, et cetera, and they're truly being transformed by IoT. And again, it's not only those hard product, but it's in healthcare, and it's also now moving into the services business as well. And really, how well we both understand and apply IoT, it's really going to determine a large extent how successful your path is going to be. And this is really a good first step. We would definitely advocate for continued education and immersion prior to investing in an IoT solution. So we have Q&A. I'm going to do Q&A in 1 second. I just wanted to share with everyone, and again, both this recording and the slide deck will be made available. We'll send that out with our partners in the Technology Association of Georgia. So TAG, that will make this available to you. You will have access to a free readiness assessment. With this readiness assessment, it's purely that you can assess the knowledge around IoT. If you do pass the assessment, you do receive, within a week, you'll receive a digital badge that you can post to your LinkedIn profile or other social media platforms of choice. So we're going to move into the Q&A. If you do have any questions, please feel free to chat to put that into the Q&A. Okay, I'm not seeing any questions at this time. Again, I'd like to thank everyone for taking the time today. We realize we're in a slightly new world at this point in time, and I realize time is busy. So one of the questions are, who are some of the major and leading companies in the IoT space? Some of them are going to be companies you recognize, HP, Cisco. But what you'll probably see in IoT, and those are obviously at devices, but it's a widely distributed industry right now. I've had the fortune to be at several IoT events. Actually, there was one this past fall here, IoT security event in Atlanta, and you literally, there's some big players that you would expect. All the cloud players are involved. As far as devices, though, what I've seen to date is that it's highly fragmented. A lot of it becomes, I don't want to say application specific, but even more so than you would traditionally see in a technology world. I think most of us are used to working, in any technology area. In traditional technology, there's 2 to 5 players that represent, anywhere from 50 to 80% of the market. And it's in like most emerging technologies, IoT is with no exception is the same. You'll see a large number of technologies from device all the way through the user interfaces. The other thing I would say is that, we expect, like in the industry, as it matures, you'll see more consolidation, but it really is a somewhat industry specific today. Yeah, and I had someone say shared that this is very complex, and it is a lot to take in. Again, I would share that you can listen to the recording back. Obviously, you can pause or fast forward to the parts that are less interest to you. Um, and we will make the slide deck available to you as well, so you'll be able to immerse yourself in that. I know that TAG is looking to provide other educational opportunities around emerging technologies to help both business and technical professionals immerse themselves in these newer technologies. One thing I would state is that we talk a lot about these technologies being emerging technologies. IDC did a report in 2019, roughly $5 trillion were spent on technology globally. And out of that 5 trillion, 1 trillion, fully 20% of that was spent on emerging technologies. So although we talk a lot about them as emerging technologies, they're used pervasively today. And it is important for us as business leaders and technical professionals to better understand. Good. Well, thank you again, everyone, for your time. Again, we'll make both the recording and the presentation available to you. Wish everyone the best of health, and look forward to speaking to you in the future. We will be, next month, we will have a similar type of webinar on data science. So we look forward to presenting that in conjunction with TAG. And doing much of what we did today, talking about the foundations of what data science is and how it's applied to business, and how that can help you advance your business. Thanks again, everyone. Have a great